In your lessons on series resistive circuits, you learned about current, voltage, resistance, and power in a DC circuit. This will help you to understand troubleshooting these same circuits. What is troubleshooting? It's the process of locating causes of faults or troubles in whatever you're concerned with. In this lesson, we're concerned with troubleshooting DC series resistive circuits. The most common troubles you'll find in these circuits are opens and shorts. So I'll stick to these two troubles. First, let's consider some examples of open. Here are some troubles that could cause an open. This one is a battery with loose connections. Most of the time, a loose connection is the same as no connection, which is the same as an open. Any circuit component with a loose connection opens the circuit and stops current. Another type of trouble that will cause an open is a burned-out component. This is a burned-out resistor. When a resistor gets overheated, its values are changed. But if enough current passes through any resistor, it can be burned completely open like this one. This lamp has a burned-out filament or lighting element, so it's an open also. Here are two other examples of opens: a switch with a loose contact and a broken wire. All of these components could cause an open, and they all give the same results. Now let's consider a very simple series DC circuit. This one just lights a lamp. By opening the switch, the current will stop. This would be an intentional break in the circuit. In this case, it's an intentional open circuit. If a break occurs at any other point along the circuit, we would have an unintentional open circuit. Unwanted opens in this circuit would be broken conductors or a burned-out filament in the lamp. I've shown you several examples of opens. An open means a condition of discontinuity in a circuit, which normally passes a current. Discontinuity is the opposite of continuity. When you have continuity, there's a complete path for current to flow. The circuit is continuous. Discontinuity means this path is broken or open. So by now, you should have a fair understanding of an open. So apply what you've learned to this. It's the first one on your response sheet. You should have written break and discontinuity in either order. Do this one. It's number 2 on your response sheet. You could have answered in many ways. but this is the main idea. The opens I've shown you so far could be found by visual inspection. That is, by simply looking the components over carefully. However, you will encounter opens that cannot be seen. In these, you'll have to use a meter that will detect the symptom that an open gives to this circuit. Here is a circuit to light a lamp. But because of the open resistor, the lamp will not light. Suppose this resistor looked all right from the outside, visual inspection wouldn't help. So how could you tell it was open? You could do this with either a voltmeter or an ohm meter. First, I could connect the voltmeter across the lamp. There would be no voltage present, and the voltmeter would indicate 0 volts. Why? Because of the open resistor. This open will not allow any current flow, so there won't be any voltage dropped across the lamp. That's why it's not lit. So what you'll get across a good component that is in series with an open one is no voltage. Now I'll connect the voltmeter across the resistor. The voltmeter has provided a path for the current to flow. Current will flow from the negative terminal of the battery through the lamp up to the right lead of the voltmeter, then through the voltmeter and to the positive side of the battery. The resistance of the voltmeter is so high that it'll only let a tiny current flow. This current is too small to light the lamp, but the voltmeter will read the battery voltage. In other words, it will read the total voltage in the circuit. The rule is, when your voltmeter is across the open component in a series circuit, you'll read the battery or applied voltage. I'll show you an actual circuit identical to this one. There are 2 batteries which together supply the total voltage in the circuit. I also have a 5-ohm resistor. This resistor is open and connected in series with the lamp. When I connect the unconnected terminal of the lamp back to the other side of the batteries, the circuit is complete. Notice now, even though I have all terminals connected, the lamp does not glow. So with the voltmeter, I'll take measurements across the lamp and the resistor. You record the voltmeter indication as I go. Spaces are provided under number 3 on your response sheet. First, we'll connect the leads across the lamp. The voltage across the lamp is 0 volts. Record that on your sheet. Now I'll move the leads and hook them across the resistor. The voltmeter is now reading 3 volts. Record that. This voltage is the same as the applied voltage. Let's check it. As you can see, the values are the same. So, when you connect a voltmeter across a good component in series with an open one, you get 0 volts. On the other hand, when you connect the voltmeter across an open in a series circuit, the voltmeter will read the applied voltage. And now you complete the 2 sentences under number 3 on your response sheet concerning this circuit. In the first blank, you should have written in something to the effect that the lamp will not light. In the second blank, you should have written in battery or applied voltage. Now that you understand the indication a voltmeter will give for an open and for a good component, let's go a step further and see how an ohm meter will indicate open and good components. I'll use the same circuit we had before. The main thing to remember, of course, is that the power will have to be removed from the circuit. If I had a switch in this circuit, I'd open it. Instead, let's pretend I've disconnected one end of the battery. Now, if I connected my ohm meter across the lamp, I'd read some value of resistance, large or small, depending upon the resistance of the filament. But the point is, there would be a reading. However, an ohm meter across the resistor will read infinite resistance, wouldn't it? So here are the rules. When you connect an ohm meter across an open component, the ohm meter will indicate infinite resistance. When you connect an ohm meter across a good component, the ohm meter will indicate the resistance of that component. So much for that. But how will a broken wire affect the circuit components? Now, here's a circuit quite similar to the one I showed you before. It consists of a battery, a resistor, a broken wire connected between the resistor and lamp, with the lower lead of the lamp connected to ground. Since the lower lead of the battery is also connected to ground, this amounts to connecting these 2 leads together, which makes this circuit the same as the previous one. Let's call the open point A. How about the voltage across the resistor in this circuit? It's 0. This voltage is 0 because the open does not allow any current to flow in the circuit. In order to have a voltage across the resistor, there must be current through it. What about the voltage across point A, the open in this circuit? You can see by